You ever have one of those moments where you just feel a little lost, looking for some kind of sign, some answer to a big question? Well, tonight, we're going to do just that. We're looking up to the stars to hunt for some of the universe's biggest, most mind-bending secrets. And believe it or not, our journey starts way closer to home than you'd ever think.
This quote just nails it, doesn't it? It really sets the tone for everything we're about to dive into. It's this reminder that for all our earthly worries, the grandest answers and the deepest mysteries are written right there in the cosmos. It's a total perspective shift, and that's what we're exploring today, from our own solar system to the very edge of reality itself. All right, so we're starting right here, in our own cosmic backyard. I mean, we think we know our solar system pretty well, right? You got your 8 planets, a couple of dwarf planets, but what if there's a giant out there? Something huge, lurking in the darkness, that we've just never seen.
So, what is this Planet 9? Well, here's the thing. It's not something we've actually seen through a telescope. It's something we've kind of felt. See, astronomers noticed a whole bunch of icy objects way out past Neptune, and they were all moving in these really strange, clustered orbits. Their paths just didn't make any sense, unless some massive, unseen object's gravity was hurting them, pulling their strings. And that invisible puppet master? That's the theory of Planet 9. And when we talk about the scale here, it is just staggering. I mean, just look at that orbital period. Neptune takes 165 years to go around the sun one time. Planet 9, if it's real, could take up to 20,000 years. It is so far out there in the cold and the dark that it makes Neptune look like it's practically our next-door neighbor.
So the big question is, why haven't we found it yet? Well, finding planets around other stars, exoplanets, is often done using something called the transit method. You basically just stare at a star and wait for its light to dip just a tiny bit. That's a planet passing in front of it. It's kind of like spotting a moth flying in front of a giant spotlight. Easy enough. But for Planet 9, there is no spotlight. We are trying to find a tiny, impossibly dim object that's reflecting a minuscule amount of sunlight, and it's moving incredibly slowly against the background of billions of other little lights. It's not an exaggeration to call it a cosmic needle in a haystack.
Okay, and here is where the story gets really wild. What if that gravitational pull we're detecting isn't from a planet at all? The most mind-blowing theory is that it could be a primordial black hole, a tiny black hole that formed at the very beginning of the universe. To have the mass of 5 to 10 Earths, it would only need to be about the size of a grapefruit. Just think about that. A grapefruit-sized black hole hiding in the dark at the edge of our solar system. How on earth would you ever find that?
So, what's our best shot? Ultimately, we just need a much better eye on the sky. And our best hope is pinning its hopes on the new Vera C. Rubin Observatory. This thing has a digital camera the size of a small car. It's going to survey the entire southern sky, over and over, building the most detailed map of the universe we've ever had. If Planet 9, or whatever it is out there, this is the telescope that's going to find it.
You know, the search for a hidden world right here in our solar system is pretty profound. But it leads you to an even bigger question, doesn't it? If we're not even sure what's in our own backyard, what about further out? So let's broaden the search. Let's ask one of the oldest, most fundamental questions humanity has ever posed. Are we alone? So back in 2022, for a brief moment, the world kind of held its breath. The planet's largest radio telescope, China's FAST telescope, picked up a really weird signal. It was narrowband, which is the kind of signal we associate with technology, not with natural cosmic events. And it seemed to be coming from the direction of a pretty promising exoplanet. Chinese state media even ran a report about potential signs of extraterrestrial civilizations. And then just as fast as it appeared, the report was scrubbed from the internet. Poof, gone. The official conclusion, just radio noise from right here on Earth. Another frustrating false alarm. And this sort of thing happens all the time. It's basically the boy who cried wolf problem for SETI, the search for extraterrestrial intelligence. From the very first search back in 1960 to that famous signal from Proxima Centauri in 2019 that turned out to just be faulty electronics, and my personal favorite, a mysterious repeating signal that scientists eventually traced to someone microwaving their lunch at the observatory. Seriously. The universe itself is eerily quiet, but our own planet is just incredibly noisy. And all of this, all these false alarms and the big, empty silence, it leads to this really famous and deeply unsettling idea, the Fermi paradox. The basic math says life should be everywhere. I mean, there are billions of Earth-like planets in our galaxy alone. So, as the physicist Enrico Fermi famously asked his friends over lunch one day, where is everybody? That silence from the cosmos is just deafening. It really makes you wonder, are we just listening for the wrong thing? I mean, 200 years ago, the best idea people had for contacting Martians was to build giant fires in the desert or use massive mirrors to reflect sunlight. We kind of laugh at that now. But what if 200 years from now, future humans look back and laugh at us? At the idea that we thought an advanced civilization would still be using something as primitive as radio waves? What if they're communicating with something we can't even begin to imagine?
This whole question of how and where we're searching, it forces us to zoom out to the biggest possible scale. We've looked in our solar system, we've looked to nearby stars. So now, let's just go for it. Let's zoom all the way out. How big is this place we call the universe? And does it even have an end?
All right, get ready for a number that's so big it's almost meaningless. 93 billion light years. That's the diameter of the observable universe. Now that's a key word, observable. That's just the part of the cosmos from which light has had enough time to reach us since the Big Bang. But that's just the edge of what we can see. It's not necessarily the edge of what is. To even start to comprehend the universe's true size, we have to talk about its shape. Einstein taught us that space and time can actually curve. So imagine you draw two perfectly parallel lines and send them traveling through space. If the universe is curved like a sphere, those lines will eventually meet. If it's curved like a saddle, they'll fly apart. And if it's flat, they'll stay parallel forever. That shape determines the destiny and the size of, well, everything. So, which one is it? Incredibly, all of our best measurements, looking back at the light from the early universe, tell us that it's flat. But here's the huge twist. Think about standing on a beach looking out at the ocean. The horizon looks like a perfectly flat line, right? But you know you're standing on a giant curved sphere. What if our flat universe is just that same illusion? What if we're just tiny beings on a tiny patch of a sphere so unimaginably enormous that it just looks flat to us?
So if that's true, if we are on a giant cosmic sphere, astronomers calculated the minimum possible size of the entire universe based on how flat it looks to us. And the number they came up with is 23 trillion light years across. That's at least 250 times bigger than the entire universe we can see. Our whole observable universe would just be a tiny bubble in a truly vast, unimaginable cosmic ocean.
Okay, deep breath. Because when you're faced with that kind of scale, it's really easy to feel small, to feel insignificant. But for this last part, I want to turn this whole journey inward, because the story of the cosmos, it turns out, isn't just out there. It's right here, inside us. Just think about the journey we just took. We started here on Earth, this one blue marble that's home to everyone who has ever lived. We zoomed out past our sun, just one star among hundreds of billions in our Milky Way galaxy. And our galaxy is just one tiny speck in a vast cosmic ocean of other galaxies, all connected by this grand, beautiful structure called the cosmic web. That scale can feel isolating, but this idea, which Neil deGrasse Tyson captured so perfectly, it reframes everything. It says that we are connected to each other biologically, to the Earth chemically, and to the rest of the universe atomically. In other words, we aren't just living in the universe, we are the universe. We're part of it. The separation we feel is just an illusion. And look, this isn't just some nice poetic thought. This is a literal, physical, scientific fact. The carbon in your DNA, the calcium in your bones, the iron in your blood, none of that stuff was made on Earth. It was all forged in the super-hot, high-pressure heart of a massive star that lived and died long before our sun was even born. You, me, every person you've ever met, we are, quite literally, stardust. Which brings us to our final thought. We spend all this time searching the cosmos for secrets, for answers, for life. But what if the biggest secret the universe has been keeping isn't Planet 9 or some alien signal or the edge of space? What if, in a universe made of endless gas and dust and fire, the greatest mystery of all is that some of that cosmic dust could wake up, look around, and start wondering where it came from? What if the universe's biggest secret is us?